Hey guys, it's Alicia from PhysZio Mags. I'm on assignment. I recently came across an article from the University of Nottingham in the UK. As I was reading the article, I noticed they were using the scientific. What is the scientific method, you may ask? Well, here are the steps. 1. You make an observation. You notice a problem. 2. You form a question. How can this problem be fixed? 3. You form a hypothesis. Brainstorm ideas on how you can fix the problem. 4. Conduct an experiment. You try out the ideas that were brainstormed. And 5. You analyze the data and collect, and draw a conclusion. Collect the data from experiments. If determined the experiment has failed, you try other hypotheses until the results are satisfactory. How to study cells. They made an observation. The cells were being destroyed using current technology. Two, they formed a question. What imaging technology can we use to look at the cells successfully? 3, they formed a hypothesis. Can you use sound waves from suboptical wavelength sound or protons? 4, they conducted an experiment. The new ultrasound microscope will use short laser pulses to generate photons which spread into the cells. The signal picks up and feeds back variations of hardness of the cell features to build up a more detailed 3D picture that would be perceptible using light. And 5, they analyze the data and draw a conclusion. Unfortunately, they're still conducting experiments on this problem. So I'm going to Japan for my assignment this week, and we are going to be looking at going to Tokyo. We're going to Tokyo and one other place. We'll get into that later. So thermodynamics. Pushing the throttle forward allows heated fuel to enter the engines, which will make the plane go faster. Fast enough to lift the plane off the ground. Once in the air, according to Newton's first law, any object will stay in motion until the pilot, by reducing the thrust, Newton's second law, once the velocity changes because of an external force, gravity will take place and the plane will begin to descend into Japan. Kinematics also play a role. As a whole, helps the pilot, his crew, and air traffic control to know his position in the sky, how fast the plane is going, and where the plane was. My first tour of the city, I stopped by Ishigamijima Astronomical Observation. They were doing a demonstration on Galileo and his invention of the telescope. Galileo used his telescope to discover the sun's sunspots on it, and that the Earth's moon was pitted just like the Earth, and that Jupiter had 4 moons circling it. He also studied Saturn and Venus. Newton's focus on gravitational pull led to the discovery that although you are lighter, the forces of gravity still follow the same rules as on Earth as in outer space as it does on Earth. My next stop, Tokyo. Tokyo has some of the best lighting displays in the world. Thanks to Faraday's discovery between electrical current and magnetism, Maxwell was able to continue to work Faraday's findings and discover the electromagnetic field that was created from magnets electrical charge. Electromagnetic spectrum is a range of wavelengths or frequencies over which electromagnetic radiation extends the spectrum, covering radiation from radio waves, a harmless radiation, to gamma rays that are harmful to humans. Visible light lands right in the middle of the spectrum. I could look at the lights of Tokyo forever, just thinking of all the ways Faraday and Maxwell worked made it possible to understand light today. Back in I'm sorry, Ishigakijima, as we were looking at Jupiter's moon, we noticed a satellite. It sparked a conversation of general and special relativity. General relativity, the tug of gravity, because of the speed in which the satellite is moving, it stays in the Earth's orbit without falling to Earth. Depending on how far the satellite is, has a factor in how fast or slow it orbits the Earth. The closer to Earth, the faster the satellite. Special relativity, came up from a shooting star as a shooting star went by. Since the speed of light is the constant, time and space are always changing. An observer noticed the star before everyone else because they were standing in a different position or angle. Thus, they perceived the actions of the star differently. Stars, just as humans and other matter, are affected by time dilation and length contraction. The faster the star moves through space, the slower it moves through time. As I headed home on my way back, I thought about Planck's work on quantum mechanics. On some flights, there is now a flight tracker where you can track how fast your plane is going, how much longer is left in the flight. It even tells you your coordinates on Earth, your longitude and latitude, with along with a map that shows the flight path. This is where quantum mechanics come into play. With GPS and satellites again. Satellites use atomic mechanics, which runs off quantum mechanics. Atomic clocks work on atoms transitioning back and forth at a precise second between two energy levels. My favorite thing to do as I enter back into Minneapolis airspace is look for downtown Minneapolis, specifically the Target headquarters, to see the LED light display on top of the building. There are exactly 700,000 LED lights lighting up the night sky with pretty scenes. Light emitting diodes are made up of semiconductors and electroluminescence, which use crystals from semiconductors to reflect the light brighter. Well, that was my quick time in Japan. I hope you enjoyed. Until next time.